Hello friends, in this video lecture we will see one problem based on CPU scheduling algorithm which was asked in GATE 1995 examination. The problem is the sequence is an optimal non-preemptive scheduling sequence for the following jobs which leaves the CPU idle for units of time, and we are having three jobs: job 1, job 2, job 3 with arrival time and the burst times, and four options are given here. Now what is asked in the question? That sequence is an optimal non-preemptive scheduling sequence. So there is need to understand non-preemptive scheduling algorithm first. In non-preemptive scheduling algorithm, process which has held resource, that is CPU, will not preempt the CPU till its completion. That is non-preemptive scheduling algorithm. And in previous video lectures we have seen that first come first serve is non-preemptive scheduling algorithm, and shortest job first, which is also known as shortest job next, is also a non-preemptive scheduling algorithm. Then next term is optimal, which was mentioned there in the question. Optimal scheduling algorithm means which has minimum average waiting time. So four sequences are given there in the options with the CPU idle time. So we are having three CPU idle time, that is 1, 0 and 5. Now let's check the first option, that is by keeping CPU idle for 1 unit time, and the sequence is 3 to 1. So we are keeping CPU idle for 1 unit. Then as per the given sequence, job 3 will have CPU for 1 unit time. Total time is 2 here. After job 3, job 2 will have CPU for 5 unit. Total time is 7. And finally, job 1 will have CPU for 9 units and total time is 16. So let's calculate the waiting time for all jobs. Job 1 arrived at 0 and got CPU at 7, means waiting time is 7. Job 2 arrived at 0.6 and got CPU at 2, waiting time is 1.4. And job 3 arrived at 1 and at the same time it got CPU, so waiting time is 0. Average waiting time equals to 7 plus 1.4 plus 0 divided by 3 equals to 2.8. Now option B is keep the CPU idle for 0 unit and for sequence 2, 1, 3. So at 0 there is only one process, that is J1. So as per the sequence, job 2 is the first process to be executed. So this option is not possible. Now we are having third option by keeping CPU idle for 0 unit time. So at 0 we are having job 1 and sequence says that job 3 to be executed first. So this option is not also possible here. So next option is keep the CPU idle for 5 units and the sequence is 1 to 3. So CPU is idle here for 5 units time. J1 will execute first, will have CPU for 9 unit time. So total time is 14. After that J2 will have CPU for 5 unit time. Total time is 19. And J3 will have CPU for 1 unit time. Total time is 20. So waiting time for job 1 is 5 because job 1 arrived at 0 and got CPU at 5. Job 2 arrived at 0.6 and got CPU at 14. So waiting time is 13.4. Then job 3 arrived at 1 and got CPU at 19. Waiting time is 18. So average waiting time is 5 plus 13.4 plus 18 divided by 3 equals to 12.13. So here first option, that is sequence 3 to 1 with CPU idle time of 1 unit gives average waiting time of 2.8. Second option is not possible. Third is not possible. And fourth option with sequence 1, 2, 3 gives average waiting time of 12.13. So amongst this first and the fourth option, first option, that is sequence 3 to 1 and CPU idle time of 1 unit, is correct. So for more such videos, stay connected here with this channel. Thank you for watching.